All right, so let's go ahead and get into this video. This video, we're going to be taking a look at the way that the media engine actually optimizes this entire algorithm. And it took a lot of time to actually get this set up. Lots of hours of head scratching and figuring out why things are the way they are. But now that I have somewhat of a better understanding, we can start to get into some of the numbers and how crazy this actually all is. So yesterday, my numbers were kind of off a bit because I wasn't overclocking. So to give a preliminary baseline, let's go ahead and just run the program here. Pretty much takes about 77 milliseconds plus 40 milliseconds. So let's call it a sum total of around 120 milliseconds on average for the entire program to run. So it's 120 milliseconds. Yesterday I said it was somewhere around 180 or 190 milliseconds, which is consistent with the fact that a 50% overclock should, in theory, give about these values. However, now with the ME, it actually takes it down by half, which I thought was really crazy. So we are actually averaging about 60 to 65 millisecond to complete world generation using the media engine, and it's doing it completely in parallel. So this will actually work for a bunch of other tasks too. But if I can go ahead and remove some of the things that I have here, I'll show you guys the actual demo. All right, so that went ahead and actually compiled now. Now we are using the full force of the media engine. And as you can see, that number is pretty nice. It's basically half. It's taking 64 milliseconds to generate 64 chunks, which, if you do the math, is about 1 millisecond per chunk. And this is including completely creating the chunk and also filling all of the data required. That's pretty cool because that means that we can go ahead and pretty much generate the entire thing in under a second. The entire map will be generated in under a second. If we say we balance a load, it takes 8 frames or so. If we are saying that we're going to use 8 milliseconds to generate, and 8 milliseconds was going to be on the actual drawing and the rest of the thread, the rest of the stuff that the game has to do, basically. That's pretty cool. And I think that this is really amazing that we're able to get such a fast result with the new fast noise light, with new optimization methods and everything. So 64 milliseconds per chunk, and then the only remaining step now is just going ahead and creating a mesh generation algorithm. And that's the only other thing that's going to really mess with the performance. And I actually have somewhat of a strategy for that. So basically, I've done a few calculations. The initial vertex structure that we're using uses floating point for everything and uses the maximum possible color. But actually, the requirements that we need are far less than that. And we can save about literally half the space by doing that. And now that brings every single chunk segment to being half the size, from 1.7 megabytes at the absolutely worst case possible, all the way down to 884 kilobytes at the absolutely worst case possible once again. Now with 40 chunk sections possibly loaded, given a radius essentially, this is about 35 megabytes total. And that's pretty good. That's a very respectable amount of memory to be using, especially on the slim models, for all of the vertexes. However, this is way higher than the average case. The average case will be fractions of this. So the average case, you can probably end up going with a full 5x5x5 render sort of cube. And you would have maybe 6, 7, 8 megabytes max of actual VRAM usage. Now, the most important algorithm that still has to be optimized is definitely going to be the chunk mesh generation. And that's not something I can actually do right here with this project without having to undergo a substantial amount of rewriting. However, this project will definitely be the basis upon which we use to work on Crosscraft. And this project pretty much proves that it's definitely possible, reasonable, and should be expected that we would be able to go ahead and implement a world system like this. So thanks for watching this short video. Today was just really all about the results, and I think it was pretty amazing to see that we can actually have the total time using the ME and how little time it actually takes for everything to work the way it does.